Good afternoon, everybody. For those who are returning, it's great to see you again. I see some familiar faces. So welcome to another summer session of EI Live K-12. My name is Cassie, and I work at the Earth Institute, which is a part of Columbia University, and this is being brought to you by the Earth Institute. And one of my big areas of responsibility is to try and get our content out to new audiences, including teachers and students and parents. And we are very lucky today to do the third part of the special summer series around the Hudson. And joining me are Laurel, Zaima, and Margie Turrin of Lamont-Doherty Earth Observatory, which is the largest research unit of the Earth Institute. The Earth Institute is actually made up of about 24 or so research centers and experts and who work in many different disciplines, including earth science and earth scientists, business and policy experts, and specialists in public health and law. And so all of these several hundred individuals actually make up the Earth Institute and work across many different departments and disciplines at Columbia. So Laurel and Margie are going to take over, and they're going to talk about migrating fish today. And we're going to be utilizing the chat box for questions and answers, but if you do have questions, or feel free to just raise your hand or turn on your camera and your microphones. They want this to be a very interactive session, and they're also going to be using breakout rooms, I believe. We would love to hear from you. If you have any questions about ongoing videos and that are part of the series, feel free to send us an email. We will be making this recording available once the session is done, and we'll be sharing that with everyone who signed up for the event through Eventbrite. And if you got the reminder email from me, you are on our list to receive the recordings. So that's it from me, and Margie and Laurel, you can take it away.
Okay, that sounds great. So welcome everybody. We love talking about the Hudson, and we love talking about fish, and this particular vista just makes me feel wistful right now. I'd love to be standing here looking out over the Hudson. This is part of the Palisade Sill. And this is taken at Lookout Point. It's a beautiful space. If any of you have a chance and haven't been there, great place to kind of peer out onto the Hudson River. We're kind of looking over towards Yonkers and Hastings, that area. My name is Margie Turrin. I'm Director of Educational Field Programs at Lamont. Spend a good chunk of our time thinking about the Hudson and exploring it. And Laurel?
Hi, my name is Laurel Zaima. I am the Education and Outreach Coordinator at Lamont. And we spend a lot of time teaching and working around the Hudson River. So excited to talk about migrating fish today.
Great. So we have a lot of different goals in mind when we put this particular set of slides together and kind of develop this activity. And I think that it has many different layers, but one of them is just getting people comfortable with looking at data and trying to develop interpretations around data. We've used this in a variety of different formal and informal environments. Informal really cut way down to a much more manageable slide deck. But in each case, it gets people thinking and talking about data and data interpretation. So we think it's a fun way to bring that in. And it also talks about something that often we don't talk about in science, and that's how important management is to science, and especially in fisheries management. So the whole idea that we as humans have an impact, and how to manage that impact is really critical. So great way to bring that in. So in terms of this particular activity, our goals today are to introduce a couple of our migratory fish and just some of the challenges of actually looking at and managing those fish. And if you were with us yesterday, we touched on some of the management issues, but you'll see today how the decision making can be just as complex as the habitats that we talked about yesterday. We're going to be thinking about the interdependence of humans and fisheries. So we're not just thinking about fish in general, we're thinking about how we use fish, and that's when the term becomes fisheries rather than fish management. We're going to look at impacts and solutions about how humans work with fish and how we can manage our fisheries better. And then we're going to use data to pose and answer questions in decision making. Again, a really important skill that we want all of our students to be able to take advantage of and really do effectively. It's part of being science literate. It's part of being really literate in terms of how we interact with our environment. So critical skills in our opinion.
Oh, Margie, can I step in just for a second?
Absolutely.
We have a poll, so if you've joined us, it's okay. If you've joined us for the past couple of days, we just wanted to know who you are after we introduced ourselves. So I'll let Nina do that.
Thank you very much for interrupting me. It was off on a tear.
Okay, we have almost everyone. I'll just give you 10 more seconds. If anyone else wants to do the poll. All right.
Okay, great. Yeah, so a little bit different emphasis today, right? I think we've had topic specialists have been one of our stronger groups in the last couple of days. So nice that we have a blend of formal, informal, and topic specialists. So that's terrific. Thank you very much, and thanks for reminding me to slow down and find out who our audience is before we jump in. So good, all good. Okay, so we are going to talk about migratory fish today and the challenges that that particular type of fish creates for management. The fact that they move into different state regions, they move between pure ocean and into our tributaries or our larger rivers, means that they are using different parts of the system and different geographic locations at different parts of their life cycle. And so actually figuring out how to manage them is important. And of course, we are interested in, we as humans are often interested in different times in their life cycle. So we might be interested in capturing the biggest fish or, really a full-grown fish. Sometimes there's a focus on eggs. So again, there can be a real diversity of interests in trying to catch those fish. So they really are best managed in a cooperative manner. So in our particular situation, there's a coastal group that works on this. It's the Atlantic States Marine Fisheries Commission, and it's 15 coastal states. So that's quite a spread. And you can imagine how exciting those conversations are when they get together, because again, every state sees a different time in this particular species. So in terms of a calendar year, they're also hitting different parts of the system at different times. Makes management really, really fun and challenging. So we're going to focus in on two specific fish. We're going to look at our American shad and the striped bass. And so just to give you a kind of a sense of them, the shad is the largest of our herring species, but still nowhere near as large as our striped bass. It runs about 1 foot to 18 inches in size, and it can get actually up to 24 inches if it's a really memorable group in the species. And their weight is about 2 to 6.5 pounds. So again, they're much smaller than our striped bass, which can get anywhere up to, well, the normal would be up to 36 inches, so 3 feet, but they can actually reach 59 inches. So quite a large specimen. And their weight, of course, is significantly higher than that of our shad, weighing up to 20 pounds in some instances. So quite a large species. Sorry, my computer is going crazy. I think maybe the weather is making the connection a little gippy here. So we are going to become committee members for today. We're going to be part of that Atlantic States Marine Fisheries Commission, and our job for the day is going to be to manage these two stocks, so the shad and the striped bass. And so we've just gotten together. It's the first meeting, and a shad fisherman has come into our meeting and he's brought some data for us to review. And he pops it down in front of us and says, this is really important. this is what you guys should be paying attention to. We need you to take action on this right now and make a management recommendation. Okay, so this is the graph that he popped down, and what we're going to do now is divide into 2 breakout rooms. Laurel will go into one, I'll go into the other, and we're going to talk around this data and see if we can answer some of these questions. Okay, and we're going to take about maybe 7 or 8 minutes to do that. So we'll go into our groups, and Laurel and I can chat back and forth and make sure everybody's comfortable, and then we'll come back and talk about it as a team. So I'll just do a quick. So we're talking about migratory fish today, and in a kind of a management way, we're going to introduce a couple of species, the shad and the striped bass, thinking about how fisheries is this relationship between the natural species and humans. Think about possible solutions to some of the impacts that we have, and then we're going to really kind of dig into some data. And so we talked about the fact that these, because they're migratory, they span multiple states. So we are gone through, for this particular group, we're looking at the Atlantic States Marine Fisheries Commission, and that has 15 different states that are part of it, and trying to come up with solutions that can help us manage our stock.
Cool.
So we're going to look at these 2 particular species, as we mentioned, and our charges that we were put into a subcommittee of the Fisheries Commission with the specific goal of managing these 2 stocks. And the first meeting, we got a shad fisherman came in and brought us that piece of data that we were looking at and asked us to really dig in and make a management recommendation. So we're trying to better understand it. And that was our first task. So do we have everybody back now? Yes, I see Laurel is back. We have more people. So that was a quick catch up for those of you who were not here when we did breakouts, because we ended up with small breakout rooms. So I'm not sure exactly where we lost people. But anyway, we want to make sure we keep everybody together. So we wanted to spend a minute and talk about hypotheses and how to effectively manage. And so we want to, first of all, let's start with, were there questions that you guys generated around the graphs? Or did you have questions when you were looking at them?
Well, we noticed that, you know, as one went down, the other went up. They were like a mirror image of each other. So one of the questions we had was, you know, does the bigger fish eat the smaller fish, right? Does the shad get eaten? So we didn't know that information, but it seemed like it was a predator-prey relationship going on there.
Okay, and so I'm going to turn this over to Laurel because I realized
Perfect.
that this was her slide.
No problem. So I'm just going to gather this on the whiteboard feature on Zoom. So if you are a formal teacher and you guys are going to be virtual this summer, this is just a great way to get collaboration, get the students chatting. So the first was, are there any questions you generated about the graph? And we have, are there any other questions?
I just have a quick question about whiteboard. You can't copy and paste onto the whiteboard at all, right?
That's a great question. I'm not sure. Should I try it?
Because I saw that you were typing. I thought maybe you were going to copy and paste it in. And I saw you typing, so I didn't know if you could do it or not.
Yeah, you
It
can.
does. Yep.
Right, it does.
I should have done that. I was nervous, so I was just
Yeah.
typing away.
Grace, I think
Okay.
you had a question when you were looking at the graph, didn't you? Put her on the
Who?
spot. Grace? About regulations? You're muted. You're muted.
Oh, sorry. Yes, we were talking about laws that came about. We were familiar with overfishing laws that came out around the 1970s, 1980s. And so we thought that might have affected the population of each species. So are there particular laws that came out?
So laws to protect these species?
Yeah, either one. Yeah.
Great.
Laura Laura mentioned certain sizes, maybe like catch and release of certain.
Ah,
Yeah, we were wondering if maybe there were laws that protected specific size fish.
And specifically the impact of the Westway litigation on the striped bass in particular in the 70s, and how that might have impacted the graph. And then just having a history of the fisheries for both species, any fisheries data other than what we saw overall would be really good. I realize you guys are recording, so I'm switching into professional mode.
so that would be what additional information, we can jump to this one. So what additional information did your group identify as being helpful or something that you would need to make a appropriate management plan?
Harvest, like just fishery data in general, harvest, you know, some of you typically, you could assume that, you know, that the economics is usually before the science. So, you know, they were keeping track of money and then somebody said, oh, this is an important species, let's do some science. And then we get Nina doing all this great stuff. So I don't know everybody here, but like, I'm sure you're all great. So yeah, some of the economic data.
So fisheries data. And I know our group had discussed some things that we wanted to know as well.
Yeah, we wanted to know some of the water quality data, what was going on in the water, even environmental activities that might be happening in the area. And we wanted to know if there were other like competing, you know, anything they'd be competing over, certain resources and stuff.
Awesome. Okay, and any other questions or additional information that you think your group needs before we move on to the hypotheses? Yes.
Can you guys remind me the dates of the graph? I looked at it fast, but
1980, 2009.
so there's definitely water quality data from that era, for sure.
We also just wanted to know too is how did they get the numbers they got? Were they sampling on one day? Was it throughout the whole year? Were they sampling different parts? Things like that. Is how did they even get the data in the first place?
Okay. Margie, were you going to ask something?
I was just going to say, no, I was going to say that Grace and Laura, we had a couple of other things that you haven't mentioned that we wanted for additional data. Do you?
We mentioned the specific years, certain events that might have happened, so significant drops and rise, looking at the data.
You guys also talking about like the laws and how, you know, what was going on at the time, right? And what was allowable?
So I know one of the things that you, and maybe this is all lumped together in competing resources, but you were also looking at where they live, their range. So, you know, that can relate to certainly the competing resource, but also just in terms of their, overall habitat.
Also, along with the range, I was interested in what the numbers in the bays looking like. For example, that feed into the Sandy Hook Bay. Have they increased or decreased, have shown any differences along with the river? Perhaps they're not even migrating up anymore and finding other places to spawn.
We also were wondering too about if there were any significant diseases or issues with red tide or something like that in the area that may have.
Okay, woo, we have a lot going on here, which I love. Okay, what were your hypotheses? And it is absolutely okay if you have more than one. I'll just, I might have to make this smaller.
So we were thinking that, Grace, and chime in here if this is not right on, but we thought that there were some laws that happened in the 1980s that protected the striped bass. And once the striped bass population started to increase, there was some kind of competition, which is what we need that information for, that made it so that the shad population decreased. This is simplistic sort of hypothesis.
So they were, sorry. So once the population of striped bass increased, then they were like, did you say competing over something that would decrease the American shad numbers? Ah,
Yes. They like outcompeted, right? Mhm.
okay, great. I'm like running out of room here because we're having such a great combo. Okay, what's another hypothesis? I know my group had one at the very beginning.
I mean, I think it's obvious. Did you guys say it already? Just the predatory, it came up already. Somebody talked about predatory prey relationship, that
Right,
the increase in striped bass is reducing the
right.
shad.
That was our initial thought, yeah.
Mm-hmm.
You guys didn't write it down yet, though, did you? All right, good.
Perhaps it could be two different things going on at spots. Originally predator prey and then overfishing in 2009. I know they did
Right. 'Cause
increase the regulations.
Yeah,
Since
it dropped at the end, right?
the drop in maybe could have been through overfishing. And hence is why I think now the regulations and limits and things like that have increased. Everybody's complaining.
Awesome. All right. Anything else before I save this? All right. Thank you guys for that rich discussion. That was amazing. I will let Margie continue sharing the presentation. Okay, perfect. So you guys hit on a lot of things that we also found would be useful information that we would need before we would actually be able to make any management decisions. So we decided we need to know more about the life cycle. We know that they are migratory fish, but what type of migratory fish are they? We need to know the range, which is something you guys also identified. What is the home range of these two species? We also talked about a potential predator-prey situation. So what is their diet? So we know whether the striped bass are preying on the American shad. Fishing pressures, also something brought up about maybe there was an overfishing situation happening. So the fishing pressures on each species, how the data was collected, what fisheries management approaches are available for you guys to use. And finally, what stock assessment approaches are being used. So you guys really hit on, I think, every single one of these in a way. So great job. So we're first going to highlight the life cycle of this fish. So American shad and striped bass, they're both anadromous migratory fish, which means that they spawn in the freshwater. So you can see on the very far left side, there is an egg of this fish. As they grow into a juvenile, they might live in the estuarine environment, but migrate back out into the marine environment as an adult until they reach their sexual maturity, where they then come back into the freshwater to spawn yet again. So both of these fish are anadromous. However, if you joined us yesterday, we did mention that the striped bass in the Hudson, they have found a nice home in the Hudson where they are the top predator. They have lots of food and a great habitat. So they aren't necessarily migrating back out to the ocean. They'll just live their adult lives in here. But yes, both fish, anadromous migratory species. Important to know. The next piece of information is talking about their home ranges. So where do these fish reside? So on the left-hand side, we're looking at the American shad. The home range is identified is the orange color. And you can see pretty much the entire eastern seaboard of the US is an area where you would find this migratory American shad species. On the right-hand side, you can see this map. You can see where the striped bass reside. They overlap in the same areas. However, the striped bass, they also go into the Gulf of Mexico area as well. So, you know, it's very possible that some of your hypotheses of predator-prey are happening because they live in the same area. But I think we also need to look at their diet. So our third piece of information is looking at what striped bass eat. So we have already mentioned they're a big fish. They're a predator in the Hudson. So 43% of their diet, they're fish. So we're looking at pretty much anything smaller than them, which is most. Bay anchovies, menhaden, which is a type of herring, American shad, another herring, river herring in general. Those are great food sources for this striped bass. But as a opportunistic predator, they also will eat crustaceans, so shrimps and amphipods, worms, mollusks, other. This picture on the bottom is actually a hilarious picture we had caught in a striped bass, put it in a bucket for counting. If you've ever gone seining, you know, you put them in an aerated water bucket so we can continue counting the rest of the fish and identifying them. And just in that short amount of time that this little striped bass was in the bucket, he had managed to try and gobble up that Atlantic silverside. So this little guy is definitely snacking. And then if we're looking at the American shad diet, these guys are primarily plankton feeders. They have a really big mouth. They like to filter feed the water. So their diet includes crustaceans, fish eggs, and maybe a few small fish, but not to the extent that the striped bass is as a predator. And this just is a really cool picture of a shad in a feeding frenzy. All right, so I think we're getting a lot of great info here. I'll let Margie take it away for fishing pressures.
You're on mute, Margie.
Oh, Margie, you're on mute.
But you sound
Well,
very
I'm talking
animated.
away and you're missing all the good stuff I'm saying. All right. So once the Europeans came over, of course, their fishing methods are a little bit different than the population that was here previously. And they start to fish to send to other communities. They really put a lot more pressure on our fisheries. And because of that, we really ended up with a depleting amount of many of our fish resources. So some that I'm sure that you're aware of, the Atlantic sturgeon. And if you joined us at all this week, you know about some of these that we've talked about, but certainly Atlantic sturgeon, shad, striped bass, American eel, white perch, oysters, blue crabs. We really extensively fish those resources. And because of that, we caused a depletion in them. And at that point, it became pretty evident that there needed to be some kind of management that would be put in place. And so one of the things that has been an effective tool for us actually came about in a kind of a reverse way. So one of the decisions that was put in place because of power companies and some trade-offs that happen with power companies is that we were funded to do these stock assessments in annual year class surveys, 3 different types. And this started way back in oh gosh, I don't even remember. It's been going on for 30 plus years. Unfortunately, the funding on this has stopped. And so the DEC has been trying to figure out how to be able to continue these assessments because they are so critically important. But there are 3 different types and they look at different parts of our fish assessment. So the Long River Survey is really looking at eggs and larva stage. They're looking at what is the young fish that are coming into the system. The Fall Juvenile Class Survey is more focused on the densities offshore. And then our Beach Class Survey looks at the young of the year that are actually in our nearshore communities. So what's in the Hudson River itself. And by looking at these different stages and different locations, they're able to really get a much better sense of what's happening with the fishery stock in the Hudson River. And of course, every piece of that Atlantic Commission has to do similar types of things. They all have similar programs that they run to try and figure out what are the stocks in their particular area. And then, of course, there are management tools that are available to us. And as we started to really put pressure on our fisheries, some of these management tools were put into place. So a few that are available are catch quotas. So you're only allowed to catch a certain number of fish, and often they will actually put a counter on the commercial fishery boats so that they are actually taking this data by an impartial individual. We have some really good relationships with our fishermen, and so often this is a self-regulatory situation where you report in what you've pulled in. It just depends on how severe the problem is and what the kinds of relationships are, but all again relate to catch quotas. Size limits are important, so there are different types of size limits that have different effects on the system. You definitely want to try and protect the spawning population, so that group of fish that are really are available to produce, you want to protect them for sure, but you also don't want to remove all of the juveniles. So you have to kind of manage this in terms of how those size limits are introduced and utilized. They can shorten or close the season. So there have definitely been instances where they have shortened the season on some of these fish, and try to, by limiting it by a week or even 2 weeks, that can have a real benefit for things like shad, which move into the system all at once and then move back out again after they have spawned. That ability to shorten the season can have a big effect because they're all coming through at a similar time. So really just cutting that time down can be very useful. The net size or the boat numbers. One of the research vessels that I've spent time on is the SUNY Stony Brook Seawolf, and that is actually a repurposed scalloper. So they had overfished scalloping, and or scallops, and so they actually took those boats and retired them and made them available for research purposes. So again, this is one of the tactics. And then establishing fishery hatcheries. So putting, raising them in captivity and then trying to reintroduce them. That has actually been used for species on the Hudson. One that I was able to participate in, which was kind of fun, was the short-nosed sturgeon. So several years back, they took some of the existing stock from the Hudson and took it to a fishery, raised it, and then reintroduced. So we were able to actually carry these from these big trucks and put them back in the river. I don't know that they continued doing that. I'm not sure what were the decision making in that situation, but it was certainly kind of a fun thing to be able to say you participated in. I'm not sure, again, why they stopped. But all of these are opportunities to try and really bring back a population and make sure that it doesn't fluctuate, back and forth. So there are different methods of stock assessment. 2 of them really focus on future reproduction, and 2 of them focus on managing the existing numbers or trying to tally the existing numbers. And these are the ways that we know. Somebody had asked, and I think it was in Laurel's group, was saying, how do we know the amount of fish that are present? How do they come up with these numbers? So again, there are 4 different methods. I'm sure there might be others, but these are 4 most common. One is stock recruitment. So again, this is looking at future production. You're looking at the possible spawn from the adult fish. So this is, we're looking at what's the potential. And then spawning stock biomass, you're actually looking at the weight of the fish that are capable of reproducing. So you look at a certain class and you're trying to figure out, what is that spawning stock biomass. So those are both thinking about the future. And then in terms of what's actually in the system right now, you're looking at either fish landings. So, what is the tonnage that's being pulled in by commercial or recreational fishing? And then relative abundance, and that's looking at it in relation to the overall fish that are there. What is the percent composition? And of course, that is of interest when you're looking at the food availability and that relationship in the system. So those are just some of the methods, and that's just for background in terms of being able to try and look at some of the graphs that we're going to introduce next. So we're going to start by digging a little bit deeper into each one of these fish. So first we're going to start with striped bass. We're going to focus in on them. A beautiful fish. Definitely these are both very iconic fish for the Hudson River, which is kind of fun. And we're going to go back into our breakout rooms, and I think probably Nina has these groups now set up so we can do this fairly efficiently. We're going to look at some data on Atlantic striped bass, and we're going to dig into it, and then we'll come back and look if you want to adjust your hypotheses or not.
So, did any group want to change their hypothesis, and would you like to share what this new data has provided for you?
Well, we were talking about maybe that there was a law that protected the striped bass. And now we're thinking like because there's such a abundance of the bass and that there's a lot of people fishing the bass, that maybe the protections were for maybe the nurseries or eggs or specifically small fish. So we kind of like honed in a little bit. That's what we got to, I think, if you guys want to add.
That's awesome. Yeah, so definitely something that our group was also talking about, just like a minor note, was when you looked at the first graph, it wasn't that long of a time range. And so the story is much deeper when you look at this long-term data set.
Cool. Okay. Oops, we did that part, sorry.
No problem. Okay, so here are a couple more facts to consider. So across the Atlantic coast, the U.S. Fish and Wildlife reported that the striped bass suffered a major collapse shortly after commercial landings peaked in 1973 at more than 6,000 metric tons. So we can actually take a peek at that in a little bit of where that falls on the graph that we just looked at. But the collapse was due to, this is what they reported, habitat loss, dam installations, which was preventing these migratory fish from making their way into their native spawning grounds. And the Atlantic States Marine Fisheries Commission cited that overfishing and poor environmental conditions also contributed to the collapse. So that was actually a couple things that our group was talking about. I'm not sure, Margie, if your group also had noted about overfishing as well. All right, so what could be done to recover the striped bass stock? What do you guys think?
I know when I spoke to my students about dam installations, though it's great for energy, creating energy, we talked about the engineering that they can create fish ladders. And so that migration helps with the migration. So not necessarily take out the whole thing, but.
Right, and there are tons of dams throughout the Hudson, like watershed area. And so, yeah, it's expensive. If you could implement some way to allow these fish to continue their spawning, their native spawning, then that would be great. So anything that could be done to help the striped bass against overfishing or habitat loss?
Well, yes, I think we were talking about like protecting where all the nurseries where the fish are born, some of the habitat loss. He has to be maybe orchestrated so that the the reproduction continues.
Mm-hmm. Absolutely. And I know we noted a couple things about what you could do to kind of help the fish in terms of overfishing. Does anyone have any ideas of what we could do in this specific case of the striped bass?
Well, I mean, they could raise limit. I mean, lower limits. One fish per person. Since it's the larger mature fish that need to spawn, you could take down and put an upper limit on the size of the fish, not just a lower limit. Way the bigger fish can make it home to spawn and make more fish.
Awesome. Laura, did you want to mention anything? I saw you were unmuted for a second.
I was going to say something very similar.
Oh, perfect. Okay, awesome.
Did
Thank
we
you
mention
guys.
the seasonal, shortening the season, the seasons for fishing? What did I say?
Yeah. Shortening the season or closing the season. Yeah, absolutely. Okay, so this was what was actually done to help with the stock recovery during this time. So fishing interventions, just some examples like you guys had said, those would be some examples. And then hatcheries were actually developed to help replenish the stock to help with that reproduction. All right, so fact number 2.
Oops, sorry.
No problem.
Try that
And
again.
there we go. Okay, so fact number 2. From 1947 to 1977, GE discharged 1.3 million pounds of PCBs into the upper Hudson. So in case you aren't unfamiliar with PCBs, polychlorinated biphenyls, they're a synthetic chemical. It was used at these power plants to help cool and lubricate the machinery. And so they were dumping this very toxic chemical into the Hudson. And it wasn't until 1977 that we realized how toxic and how damaging this is to the environment. But by that time, it had already spread throughout the Hudson. So from the upper Hudson to the lower Hudson. And so the challenge with PCBs, as I'm sure some of you are familiar, are that they're really a long-lasting chemical, that they don't flush out of the system. They actually bind to sediments and can become very stable in the environment. When they are consumed, let's say any bottom feeder is consuming these sediments, then they're accumulating PCBs in the fats. And of course, like any chemical, they biomagnify up the food chain. So striped bass being a top predator, they're pretty vulnerable to PCBs. And so in 1985, this is the reason why the New York DEC closed the commercial striped bass fishery in New York Harbor along the Western Long Island area because of the PCB contamination. So striped bass, they are a pretty fatty fish. They're at the top of the food chain. They have a lot of PCBs in their system. So they closed the commercial fishery as a health reason to prevent humans from consuming them. So in addition to the closure of this fishery, there were some big landmark environmental policy decisions that happened during this time period that helped protect striped bass and their habitat. And so if you actually joined us yesterday, we talked about some of these. So the abandoning the construction of the Westway Highway, which would have filled in and destroyed an overwintering area and essential spawning area for striped bass. That really helped protect this population, as well as abandoning construction of Con Ed's hydroelectric plant that they had proposed at Storm King. So that would have sucked up a lot of the juvenile eggs and larvae and would have done a number on the fishery as well. So these 3 big things that happened during this time period really helped them to kind of bounce back. So just to go into a little bit more info about PCBs. So we didn't actually start cleaning up the Hudson until the 2000s because we didn't have a full understanding of the problem with PCBs. We thought that they would actually just get flushed out of the system, which is not the case. As we just discussed, they really bind to the sediments and they're pretty stabilized. So there was a huge cleanup that happened in the upper Hudson where they dredged a lot of the benthic habitat and sediment to try and get the PCBs out of this environment. That definitely helped lower the numbers in the upper Hudson. However, nothing is ever perfect and clean when you do a big cleanup with toxins. So every time you dredge with this giant crane, you're picking up the sediments, but inevitably you're stirring up the sediments into the water column. So then you're kind of resuspending the PCBs in that area. So long term, it definitely had a positive impact. It cleaned up that area, but the short term, there was some impact, unfortunately. But if you compare the cleanup in the upper Hudson, the PCB numbers are much lower, whereas in the lower Hudson, where there wasn't any cleanup done, even back to the 70s, the PCB numbers have remained quite stable back from the 70s, which is pretty crazy. So that's just a little bit more about PCBs. And if we look at these 2 facts that we presented on the graph we were just looking at, the peak of landing, so tons of striped bass, I think 6,000 metric tons of striped bass happened in 1973, that peak right there. led to this steep decline of striped bass numbers until they closed the fishery in 1985. And they didn't close the fishery because of the decline. Remember, they closed it because of the PCB contamination, but it ended up really helping their population numbers. So we do see this kind of rebound happening right after.
Okay, so we're going to move now and take a little up close look at our shad. So we're going to dig deeper. This is, oh, my video. Come on, play. So this is herring moving in. The riverkeeper took this underwater video. I think it's also always important to take a deep dive and look at the fish if you're going to talk about them, right? They're so beautiful. They're so determined. Oh, go ahead.
They are. Oh, I was just going to say, that was one of the things that we learned was that, you know, students, they learn about these fish, but they want to know what they look like and how they swim and how they move. And I think this video tells a great story that these fish, they are also a schooling fish, that they're moving together. Pretty cool.
Yeah. Yeah, and they're all moving exactly right. So they're all moving in on their way into the estuary, which, you know, it kind of, if you're going to be talking about, especially with shad, because they have this very seasonal entry into the river, it's nice to be able to just show that movement as you're going forward. Okay, I didn't mean to do that. I meant to do this. So, we're going to do one more quick launch into a breakout room. We're going to do this 5 minutes at most. If we can do it faster, let's do that. And everybody that's on here, let's not get lost. Okay, everybody has an assignment, right, Nina? Okay, all right. So we're gonna go into our breakout rooms and we'll do a quick discussion about this particular graph, okay? Did anybody, any group want to change their hypotheses at all? I know ours discussed some kind of nuances to it. Laura, do you want to share what you were mentioning?
I was just saying that, you know, we would have just changed that little bit about how when the striped bass population increased, that they are eating, we think they're eating the shad instead of that they're competing for our resources.
Okay, yeah, so we had talked a little bit, but not really gone hard on the predator prey, and I think they feel more strongly about the predator prey here. Did the other group, anybody in the other group, did you change anything?
Are you saying that it is a predator prey?
I'm not saying it is. I'm saying that was an adjustment to our hypotheses. We
Yeah,
haven't gotten to the bottom of this yet. Okay, stay with us.
You're leaning more towards the predator prey?
Our group wanted to modify their hypothesis to lean more heavily on that, but there is much more here. Okay.
I mean, I don't know if I could speak for everyone in our group, but we're thinking the opposite, because since before 1980, both species were doing well at the same time.
And I think Kirsten had a good point as well.
We were looking at two different environmental conditions. One was whether or not the shad was maybe a bottom feeder and picking up the PCBs. And the other one was we've had such a temperature issue in the Hudson recently, especially with this year and the big fish kill with the temperature, that maybe it might be a temperature issue. So we were looking at other environmental factors.
Okay,
We
cool.
also had that discussion about PCBs and maybe the shad were eating the PCBs, but it turns out they don't actually eat in the Hudson River.
And the graph is it's not just the Hudson River. It's apparently
right
a larger area. It's not just the Hudson River, so it can't be specifically to that.
Oh, that was one of our questions and I couldn't remember. So this shad is the Eastern Seaboard. Okay.
Yeah, this one is. We should also label these. So there, you guys are bringing in some good things that we need to clarify on here. So I think that that's really an important question. And yes, you're absolutely right. There were lots of discussions going back and forth in both groups. And I think that you can see that this could kind of create rich discussion in your classroom, which is very cool. Okay, so very cool. So Laurel, is this me or is this you? I can't remember who's doing what.
This is you. I'm sorry. Maybe the graph was me. We're getting twisted, but yeah, go ahead.
Okay, this is hilarious. Okay, so 3 days of doing workshops together, and it's hard to figure out who's doing what where. So we wanted to go into.
Each other.
Pardon me.
But you're so nice to each other. You work so well. You're like, this is.
we do get along well, which is good because we work together a lot. Okay, so we're gonna just roll out some additional facts on the shad like we did with striped bass. So the first thing is that in 2007 there was an all-time low, right? So coastal wide, the shad just really went down steeply, and there was no real evidence of recovery. It was a very lengthy conversation that was had by the Atlantic Commission, and there was a lot of angst around it. And they came up with the primary reasons for this being overfishing, pollution, which you guys were talking about, different environmental factors. So low dissolved oxygen levels in spawning areas. If you joined us yesterday, you'll remember that these guys really are very environmentally sensitive. They have pH requirements, oxygen requirements, even sediment requirements for when they lay their eggs. So they're very, very specific. And then habitat loss due to dam construction. So in the Hudson alone on those tributaries, as Laurel mentioned, there are literally thousands of dams. There's over 6,000 dams in those tributaries. So just, all this kind of conflict has created challenges for a fish that's fairly sensitive. So what could be done to recover the American shad stock? What do you guys think?
I'm guessing setting up fisheries and hatcheries.
Okay, so hatcheries, okay. Any other ideas?
Fishing limits.
Fishing limits, okay. Yep, fishing limits.
I would argue that they're in order of what's easier to fix. So overfishing, you could set policy. Pollution is a little more work, but finding sources and mitigating it. And then habitat loss is hard to undo, especially with construction. But somebody brought up, I don't know if shad respond to ladders or not, or how you can, if you have to take down the dam or you can modify it.
So one thing I want to say that Roy has shared when he first started talking with us is that he thinks economics is a primary driver of a lot of this management decision. And so the assessments are all really about the economics of things. And I think your points are right in line with that, that, you really need to go to what's easiest to do first and match ease with actual impact. So really important points to kind of talk about with your students. So we're going to look at
the more economically viable fish is the one that brings in the most money. Is it the striped bass?
That's a really good question. So striped bass is a huge industry, and it's not, so I don't want to say that shad fishing is a niche industry, but it's a very specialized group of fishermen that fish shad. The shad itself is filled with bones. So there are, although it's a well sought after fish and has been in this, used for many, many hundreds and hundreds of years, as we were talking about in our particular group, Civil War, American Revolution, like it's really been a mainstay. It was the first commercial fishery in the New World. Striped bass is probably more of an economic and sought after fishery. Would you agree, Laurel?
I agree. Yeah. I think in the Hudson, there's like a special relationship with shad that other places don't have.
And recreational people will go out and fish striped bass for recreation. More like shad, that's not a recreation fish.
Right.
Absolutely right. So one of the things that we kind of chatted a little bit about in our group was that the shad, they run the rivers. So they come in, and that's why that wonderful video is so great. They hit in late March, they come in, and then they go back out. So they're not here for those recreational fishermen, really. Those recreational fishermen, the diehards are there in March, but most of them are coming a little bit later than that. And they're not gonna really pick up a whole lot of shad because the shad are long gone. And the shad come in like a mission.
What's the fishing season? I don't fish, so
I actually grabbed the sheet off my refrigerator because I haven't had one.
Go for it, John.
And it was interesting that basically there really isn't much of a limit on shad. I found it very surprising since they are in such dire straits. So, I mean, that's either like I think Roy was saying that it's not really a recreational fish to begin with. So I guess they don't even bother regulating it for recreational fishermen. Because there's no sea, it's open all year round.
Oh, wow.
So it is,
No limit
yes.
on size.
It is definitely not a recreational fishery. The recreational fisheries, so recreational fishermen are interested in the big catch. They're interested in the aggressive fish, you know, the ones that are really fun, quote unquote, to fish. And so striped bass would fit that bill really, really nicely. But thank you for sharing all of that. Based on this, the Atlantic Fisheries Commission decided that they would limit, so ocean harvesting, you know, done, they stopped it. And basically then that moved it into individual states. And so each state was required to submit a sustainable fisheries management plan. And they had until 2013 in which to do that. So that is an interesting tactic. They close off the ocean, okay? But then that means that all these individual states have a little bit of latitude in terms of delivering a plan. I don't know, it's an interesting approach and one that you could talk about with your students, whether they think that would be the appropriate approach or the non-appropriate approach, but that is in fact what was done. So in your minds, does closing the fishery in the ocean but keeping it open actually in the rivers, is that really the best thing for the shad population? What do you guys think? Anybody want to weigh in on that?
They spawn in the rivers?
They spawn in the tributaries.
Is there a fishery in the ocean for shad? I thought it was mostly in the river.
There's a little bit of both, or there
Okay.
was a little bit of both. And there's, of course, there's also the bycatch, but we can't, you know, that's not the focus.
I mean, if they keep the fishery open in the river, you're just going to be fishing out, you know, young shad.
It's easier to catch them in the river, that's for sure. It's very predictable. So, and
So
they're
that
going
is
to
in fact
breed.
a very interesting point, Roy. So first of all, I want to say that we tend to be, it's like almost 1:30. We have about 3 more minutes. We'd like to get through this. We have, like we said yesterday, we have a few more minutes of time. Is everybody willing to stay with us? Because you guys have been such great discussion people, we're running a little bit late, but we're going to try and keep moving this forward. So I think your points are really well taken in terms of that if in fact it's easier to catch them in the river, and it's because they put out these, like, it's like running the gauntlet. They put out nets on either side and the fish basically run down the river, run up the river on their way to spawn. And so picking off these fish is just easy. Like, this is not a challenge for people. Hence, putting them back into the hands of the states could be considered a questionable move, right? So I think that we've kind of
be a really interesting discussion with the students, and even like kind of relating to COVID in a way. Like, if you're a state who wants to protect the fish, you're doing the right thing and not doing it and letting them thrive. And then the state that says, no, we're going to keep economics open, we're going to fish it, they're going to be the ones who benefit from all of that, even though the other state is the one doing the right thing.
You're absolutely right, Kristen. That's a great point. And you're right. It'll be much more relevant to them now because they've seen this play out in a human element. So really a great point. Yeah, very cool. So Laurel, I'm going to turn this over to you because I think I've talked a lot. I think I talked into some of your slides.
It's okay. Okay. So fact number 2, so this graph, let's see, spawning stack biomass. If you guys remember, that's the amount of fish that are sexually reproductive, their biomass. So we're looking at recruitment potential here. This was so 2005 was the end of the first shad graph that we looked at. We're going into 2012, and right here, that circle right there, that's 2010. That was actually the, oh, do we not want to do that bit yet?
You know what? I think it
Maybe
all
we don't
looked
want to do that bit.
together. I'm sorry. I don't know why it did that. I think somehow it, anyway, just go for it because we're kind of
Okay.
tight on time.
All right. So would you guys, okay, I'll just go for it. So in 2010, the New York State Marine Fisheries Management Team, they actually decided that the shad, commercial fishery, and recreational fishery are closed. Closed, done. It had depleted so far from like historic numbers to such a low level that they had to close the fishery. Excuse me. Okay, so thanks.
All right, that was our note.
It's hard when I can't, yeah. Okay, so we can go one more slide too. For the shad, was this the cause of their decline? Was it overfishing, or are there some other factors that we have to consider as well to some, like Kristen's point earlier? So some other things that are important to consider, especially Hudson River based. We have used the river for a lot of industry. So we definitely have power plants up and down, maybe more historic, but they still have an impact. So when they would cool their machinery and put that warmer water out into the Hudson, that increased water temperature actually impacted these fish populations. It caused a lot of stress. It caused a lot of fish die-off. Even their twice cooling has an impact. So that's something to consider. Ocean bycatch. So being a migratory fish, these fish, anadromous, they live most of their lives out in the ocean. So when you have big trawls coming through, these fish, even if they weren't sought after, they can be a form of bycatch, which kills off their numbers. Habitat and spawning grounds have been lost. We kind of noted that. Also playing, like dams play a role in that for sure as well. The river is also warming. So this is something that we talked about in our group. It's warming, and we've seen a lot of these really sensitive species are lost. So species that we had in the Hudson, the rainbow smelt, doesn't exist anymore because the temperatures are too warm for them to survive. And if you didn't join us yesterday, one thing that we really talked about was when you have a warmer water temperature in the river, the water isn't able to hold as much dissolved oxygen. So it's not just thermal stress, but it's also the lack of oxygen for these really sensitive species. And herring, they're one of those sensitive species for sure. Overfishing definitely plays its role that we kind of talked about, but you also have to think about invasives that change the ecosystem. They're specifically talking about zebra mussels, but there are a handful of invasives that live, reside, and kind of have really established themselves into the Hudson as well. And we got low oxygen, which is tied up right in that water temperature. Okay, so we want to give you guys time to work in your teams to create your final recommendations. So after looking at both pieces of data, focusing on striped bass and focusing on American shad, do your first hypotheses hold up? Would you change anything? And then finally, what would your recommendations be for each one of these fish species? And so just to give you a little bit more information, these are some fishery management tools that you can use. Just to do a quick review: catch quotas, so the amount of fish that you can actually land, catch, and bring in. Size limits, which prevents you from catching juveniles or maybe spawning females or spawning fish that are sexually mature. Shortening or closing seasons, which we've seen historically in our facts, have definitely helped rise numbers. Net size or boats, and establish fish hatcheries. So those are things that you can definitely implement in your teams. And then we also just wanted to provide you with some vocabulary. This might be information that your students would want printed out so they can talk around together, but maximum sustainable yield is the largest catch that can be taken from a species while maintaining its sustainability, so allowing that population to continue on. A target fishery management goal for the overall stock size and fishing mortality, and then thresholds. So targets are the level of management aims, and thresholds are the very bottom level that they really try to avoid. So thresholds are like the limit. Like you don't want to exceed your threshold that you've set. If you exceed your threshold, then you would not be following within that maximum sustainable yield. Okay, that's just some vocab. Your students can add it to their management plans, or you guys can add it to your management plans.
So Laurel, I'm looking at our numbers and I'm thinking about our time, and I'm wondering if we just want to do this as a total team. Do you want to do that?
Let's do
Okay,
that.
why don't we do that? So I can go back to the question slide if we want to do that. There we go. All right, why don't we do this as a team, and then we just have like 2 quick slides after that. All right, so what do we think on a hypothesis? What do we think really was going on with these, with what our fishermen first brought in? That wonderful graph. Do you think that that's telling the story that you originally thought it was?
Well, you know, they say correlation doesn't necessarily mean causation, right? So perhaps there was more detail, like there's more to it than the simple idea of just this relationship between these 2 fish.
I think that's the basis between the relationship, and that there's just a lot more external factors that are affecting that initial relationship.
So go back to that again, Kristen. So when you say it's the basis, can you expand on that a minute?
I think that, you know, before we got involved, that's like the base relationship is that inverse relationship, and that we've added in these external factors that have altered that relationship.
Gotcha. So the human element has altered this. Okay, that's the part I was missing. Thank you.
I was going to say anthropogenic, but the word was getting.
Yes, no, that's fine. Anthropogenic, you got it.
From a point of view of looking at data, I think it's also important to realize that sometimes data is just a snapshot of a point of time, that you have to see the whole picture in order to really make an informed decision. So because the original one only went to whatever it was, 1980, but then when you saw the population of the shad and the striped bass to the 1950s, you could see a different story there, and that inverse relationship overlap wouldn't hold.
Yeah, I think you're absolutely right. And also you guys started by generating all these lists of things that you thought would be useful to you to have to help you make these decisions. And that also added to this. So there was a lot of additional information that really needed to be pulled together and reviewed before you could just make a quote unquote snap decision on what was that relationship. So I think, you know, I think you guys can see that there's a rich amount of discussion that can happen around this, and a lot of opportunity for teaching about data, working with data, getting them thinking critically, getting them kind of thinking broadly. So I think that it's got some really fun uses in a classroom. Would you have any recommendations for a management plan? Just curious.
I love the idea of creating new hatcheries.
Okay.
I think that's a great, it's very positive, it's moving forward, it's expanding. I don't know, it's a feel-good solution. I like it. It's not saying you can't, it's saying we can do more.
I like that. So
I would add,
yeah,
not to get too political, but with students funding science, and then making decisions that are evolving with what's happening with the data is a great takeaway lesson. So there's not maybe just one management plan. You know, obvious. I mean, this is obvious to us, but to students, you know, correlating the economics and the science and the, you know, the environmental impact into evolving plans. So like the easiest thing to do is to shut down a fishery, but that has economic and, you know, implications. So like, how can we monitor the fishery and, you know, like using maybe the, you know, it'd be nice is using the Alaskan salmon fishery rules that constantly evolve to correlate with the management plan, like as a case study with the kids.
Oh, that's interesting. Yeah, so case studies are great, and you're absolutely right. Being able to model it on something that pre-exists is great. We didn't pull in a management plan, we just pulled in some tools for you to look at, but those management plans can get rather elaborate. It would be great to just kind of cull it down a bit and have a chance to look at it. I did want to introduce, I don't know how many of you know John Mylod. I think probably Roy does. I don't know if others of you do. Nina, maybe you do as well. But John was a shad fisherman before they closed it down. He's a wonderful person. He was also involved as a director of Clearwater for many years. So he's worked both sides, the actual fishing the river as well as trying to protect. And I see that as no conflict in John's life. He's very much an environmentalist and a fisherman living off of the river. He still fishes blue crab, which is the only commercial fishery left on the Hudson. A heck of a guy, and it's for, meeting real people, I think is also kind of a fun thing. So knowing that there's actually a face to the fishermen out there is another completely fun thing. I did want to just share with you that in fact, even though the striped bass in the Hudson does not seem to be diving down rapidly, in terms of so part of this is because we're part of this wider group, restrictions that affect everyone, even though they might not actually be in place in our particular system. So the fact that the striped bass fishery in the Hudson was closed a while back means that our numbers have continued to be healthy. But because they are dropping elsewhere, there was a requirement that the Hudson River Management Group put in place some kinds of restrictions. So there are now size restrictions trying to protect this spawning stock, especially the female spawning stock, and keeping our takes to this middle group, so not the very young of the year, but this middle size group, and as well as what they call the trophy fish. Everybody has a plan right now, right? And this was the Hudson River plan. So again, this was one that was designated back to the states to come up with an approach or a method. And with that, so Laurel, do you have closing comments or thoughts? And I apologize, I think we really jumped in back and forth on each other for this one.
No, it's totally fine. Yeah, so I just wanted to let you guys know that one of the conversations that can kind of spiral out of this that we had with our students was, so our students, they're very environmentally focused. So they were like, close the fishery, close all the fisheries because we need the stock to recover, which is in theory great. But there is this humanizing component of John Mylod's story of these commercial fishermen on the Hudson that their whole livelihood for generations has been fishing this fish. And so overfishing may played a role, but is not the only reason. And so for this fishery to be closed and for them to be like, quote, quote, out of a job, that was really hard for them. And there was a huge debate going back and forth. So there is this like deeper conversation that you could have. You could also talk about just the challenges of trying to manage a migratory fish. For example, one of the conversations we had was one of our students was like, I think we need to close our fishery in the Hudson. And I was like, okay, what if we closed our fishery, but let's say the fishery in Delaware is just no rules, no regulations, fishing to maximum, like ruining the fish population. And then our Hudson River fishermen are the ones that are being impacted negatively, even though they're following the rules, kind of like what Kristen had mentioned. And our students were kind of like, yeah, I didn't really think about that. So, I mean, there's a lot of amazing, rich discussion that you can have after they've dug into the data on this.
Right, especially because those fish move all the time. So it's not as if they're staying put in one place. Okay, any questions from any of you guys? We will be sharing out all the slides. So you'll get that, you'll get the supporting material.
I have a question. What's the updated, is there an updated data? That was, I think the one was 2009, so it's now.
For the shad?
Yes, or both.
Yeah. Or for both. So they no longer collect in the Hudson River the striped bass data because with the fishery closed and with the there's no impetus for them. So we have gone to them and asked them if we could get updated data, and the fisheries guys have just said, you know, they don't have it either. And I think it's going to be even more challenging now that the funding has run out on a lot of the surveys. They're trying to figure out how to fund some of this work ongoing, because as we all, well, I think most of us are aware, long-term data sets are invaluable. They're like gold. And, you know, of course, they're hard to continue to fund, and trying to find another mechanism so that we actually have this in place is going to be really critical. In terms of the shad, I will tell you that those numbers have not recovered. It's been a very puzzling situation and it's been a hotly contested discussion, because the fishermen had said early on, it's not us, it's a bigger problem, and you're penalizing us for this bigger problem. But as we know, the numbers were so far down. The DEC representatives that were in place at the time, Kathy Hatala said, I can't in good conscience, you know, leave this fishery open. It's just not sustainable in its present state. So they're still trying to figure out if there are other things that they can do. But it's definitely an ongoing discussion.
Thank you.
Great.
Well,
So
thank you.
everyone. I'm sorry, were there any more questions? Okay.
Have a great school year, everybody.
Thank you.
Yeah, so we'll be sending out the recording for this and some supplemental resources to go with it as soon as we can. We don't know exactly when that'll be yet. Please feel free to email any of us any questions that you might have. And if you'd like to email Cassie any feedback that you had about the sessions this week, that would be great. Thank you so much, everyone.